Hello geniuses! Welcome to Vidwath Academics. I'm your maths tutor Devika. Today we'll be studying a very interesting concept in class 10 mathematics called coordinate geometry. I'm sure you have all studied coordinate geometry in your lower classes, but we need a few basic concepts that you have already studied to go into the depths of today's concept. The very first thing that you need to know is the concept of a plane. What is a plane? I'm sure you have all observed the whiteboard or a blackboard in your classroom. That surface is a plane surface. Why do we call it a plane surface? In mathematics, a plane is a flat, two-dimensional surface that extends infinitely far. Consider this board for example. This board is a flat surface. Also, it has two dimensions, namely the length and the breadth. Also, I can extend this infinitely far. Therefore, this surface is a plane surface. In mathematics, we also come across the concept of coordinate plane. What is a coordinate plane? A coordinate plane has an x-axis and a y-axis which are used to locate points on a coordinate plane. So, what is the important thing that you need to have on a plane for it to be a coordinate plane? We need to have two axes. The x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. The x-axis and the y-axis, they intersect at the point O called the origin. Why do we need these x and y-axis? Well, if I need to come and visit you at your house, should I not know the address of your house? The address or the location makes it easy for me to reach you at your house. Similarly, for us to locate any point on the plane, we need this coordinate axis. Using this coordinate axis, we can define address or the location of a point on the coordinate plane. For example, consider this random point on this coordinate plane. For me to locate this point on the coordinate plane, I can draw perpendiculars to the x-axis as well as perpendicular to the y-axis from the point, let me call it as A. The perpendicular from the point A to the x-axis meets the x-axis at the point 6. Similarly, the perpendicular from the point A to the y-axis meets the y-axis at the point 5. Therefore, I can write the address or the location of this point within brackets as 6, 5. That is, I am writing an ordered pair where 6 gives us the x coordinate, also known as the abscissa, and 5 gives us the y coordinate, also known as the ordinate. This is how we locate a point on a coordinate plane making use of the x and the y axis. Also, we can find the distance between 2 points on a coordinate plane. Consider this coordinate plane. Here we have the x-axis, y-axis intersecting at the origin. Let me consider a point A. The coordinates of this point will be 5, 0. Also, let me consider a point B. The coordinates of this point will be 0, -4. I can find the distance between the origin and the point A. That is, I can find the length or the distance OA. To do that, I need to only measure from the origin to the point A. That will be 1, 2, 3, 4 and 5. 5 units is the distance OA. Similarly, the distance OB can be found by measuring from the point O to the point B. That will be 1, 2, 3, 4. 4 units is the distance from O to B. Notice here, even though the point B is on the negative y-axis, the distance is always positive. Always keep this in mind, the distance is always positive since distance is nothing but length and length is always positive. And we write here as units because we do not know if the unit taken here is centimeter, millimeter or inches. It all depends on the scale of the x and the y axis that we consider. I hope that's clear. Now, how will I find the distance between the points A and B? Well, to do that, it is not feasible for me to directly measure between the points A and B. It would be easier if I can come to a formula which using which I can get the distance between both these points. The formula that I'm going to get is called the distance formula. The distance formula is used to find the distance between any two points on the coordinate plane. And for me to make use of the formula, I need to know the coordinates of the two given points. Let me take the coordinates of the 2 points as x1, y1 and x2, y2. Here, P be the point having the coordinate x1, y1 and Q be the point having the coordinate x2, y2. I need to find the distance PQ and the formula will be given as such. Let me show you how we come to this formula. Let me show the derivation of it. In order to find the distance PQ, let me first draw a perpendicular from the point P to the x-axis, meeting x-axis at R. Also, let me draw a perpendicular from the point Q to the x-axis, meeting the x-axis at the point S. Now, let me also draw a perpendicular from P to T. Also, let me draw a perpendicular from the point P to the line QS, meeting QS at T. We can notice here that the angle T formed here is a 90-degree angle. Therefore, triangle PTQ is a right angle triangle. Triangle PTQ is a right angle triangle. Therefore, I can make use of the Pythagoras theorem. Using Pythagoras theorem, what does the Pythagoras theorem say? In a right angle triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. Here, the hypotenuse is the side opposite to the right angle. Therefore, the hypotenuse is PQ. So, hypotenuse squared is equal to the sum of the square of the other two sides. The other two sides are PT and QT. Is equal to PT square plus QT square. PQ is the distance that we are supposed to find. So, I'll keep it as it is. In order to find the values of PT and QT, I'll make use of the given information that P and Q's coordinates are given. Since P has the coordinates x1, y1, I can say the distance OR is x1 and the distance PR is y1. Similarly, with the information that the Q has coordinates x2, y2, I can say the distance OS is x2 and the distance QS is y2. Also, if we notice, the distance RS here is nothing but x2 minus x1 and the distance QT here is y2 minus y1. Now, we see that PT and RS are parallel to each other and are of the same distance. Therefore, PT is also equal to x2 minus x1 and QT we have found out that it is equal to y2 minus y1. Simple, isn't it? Now, let me substitute the values of PT and QT into our equation. Therefore, we get PQ square is equal to x2 minus x1 square plus y2 minus y1 square. Since I need to find the distance PQ, here we have PQ square. Therefore, I'll take square roots on both sides. Therefore, I get PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now, this is nothing but our distance formula. Pretty simple, isn't it? Let me go through what we have done again. We have taken 2 points P and Q, joined them, and we are supposed to find the distance between both these points. To do that, I'm making use of the Pythagoras theorem. That is the only theorem that I'm making use for the derivation of this formula. Now, we have just seen how to derive the distance formula. We need to yet know how to make use of the distance formula to solve more and more problems, even more real life problems. But we'll see that in the following session. Until then, do not forget to subscribe to our Vidwath app. You can also follow us at all these social media platforms. Until next time, keep understanding, keep practicing, keep studying and enjoy math.